Now, in the previous discussions, the continuation is that in this continuation, chain rule. Why I am using this chain rule for finding the some problems you have to how to remember. Suppose f is a function in terms of f of x y, two variables is given, where x is in terms of some t function and y is also in terms of t function. H of t is some function, just like x equal to t square plus 2t plus 4 is there. X is in terms of t, x is in terms of t. Similarly, y is in terms of t. How find dou f by dou t? How will find? How will write for dou f by dou t? Means you have to remember the chain rule here. Easy way of remember. See here how to write. Don't buy out this one. How to write we have to remember. A function f is a function is given. This term function in terms of x and y. Okay, x in terms of t, and y is also in terms of t. Okay. So the way of writing here is the firstly the two terms I am writing as dou f by dou x. 1 minute. Here I am writing as dou f by dou x, and here also dou f by dou y. And these terms here between here x and t I am writing as differentiation dx by dt, and here dy by dt. Okay, here I am writing as two functions, here I am writing as dx by dt. So f and t related, the way of writing is dou f by dou t equal to multiply these two terms, dou f by dou x into dx by dt, plus dou f by dou y, into dy by dt, This is the way of writing dou f by dou t in this process. So this chain rule, if you remember, we can write directly like this. Okay, clear? If they give the one equation with respect to x means directly we can solve. Like this, with respect to 2 means how we can solve? We can't solve it. If you want to solve means, remember this chain rule like this. By writing like this table, like a tree like this, we can write easily way dou f by dou t, whatever we require terms, easy we can write it. Suppose if we have the terms in the two variables, for example, just like 1 minute, I'm writing. This is the way. Suppose here x is in two terms, just like t1 comma t2 is there, and here t1 comma t2, two variables. Here x in terms of 2, just like 2t1 square plus 3t square, like this. 3x plus 4y, x and y are two terms, like that. T1 t2 are the variables. That means here also we have to find the dou f by dou t1, how we will write it, and similarly dou f by dou t2, find dou f by t1, how we will write, means same sign rule. In this, f is a function in terms of x, y. X is in the terms of t1, t2. Similarly, y is in terms of t1 and t2. Just before how we written, the same format, let us write for the terms. Here, dou f by dou x, here as dou f by dou y, and these terms we will write as dx by dt1, and here we write as dx by dt2. Here with respect to y means you write here this term is dy by dt1, and this term here is dy by dt2. Now with respect to t1 means you continue t1. Here is t1 here. With respect to t2 means here f and xt, here and f, y and t2. So how will write means here the way of writing is, I am writing this term dou f by dou t1 equal t1 I need. Multiply these two terms, t1 related, dou f by dou x and dou f by dou x into dx by dt1, dx by dt1 plus, and here t1 related only. T1 related means this term, this line, dou f by dou y into dy by dt1, dy by dt1. This is the way of writing df by dt1, way of writing like this procedure. Similarly, if I need dou f by dou t2 means t2 related, this is the t2 related means dou f by dou x into dx by dt2 plus dou f by dou y into t2 dy by dt2, dy by dt2. This is the way of finding dou f by dou dt2. So this is the chain rule. This is for two variables. Previously I explained for the single variable, but the two variables only, but x in terms of t, y in terms of t, that is node 1 and this one is node 2. Okay, this is for of way of writing the procedures if x in terms of two variables like t1 t2. This is nothing but x1 y1, like this you can assume it. Okay, that means suppose x is there, x in terms of t1 t2 means like this, t1 square plus 2t2, like this is there. This is x is in terms of t1 t2, y is also in terms of t1 t2, like these terms are there. To find out the dou f by t1, this is a procedure. Okay, thank you.